Good afternoon, geometry students. I wanted to go over the first half of your Unit 4 test review, and I will do the second half on a video tomorrow. For the first problem, we have a bunch of triangles attached together. Your pictures and your numbers could be different than mine, but they should be similar. So the first thing I noticed was triangle 1 and triangle 3. They both have the angle with one arc mark. Then they have this side, which is attached to that angle that has one tick mark. And then on the other side of that segment are the angles with the two arc marks. So I could say that triangle 1 is congruent to triangle 3 by angle side angle. And I also noticed triangle 2 and triangle 4. They had the side with one tick mark, the angle with one arc mark, and then the side with two tick marks. So these two would be congruent by side, angle, side. And I mean, a lot of them share different stuff. Like if I looked at 4 and 5, they have a side in common. They have the angle with the one arc mark, but that's it. And that's not enough to say that they're congruent. And let's look up here at triangle 2 and triangle 3. They also share a side. They have the angle with the one arc mark, but again, this has 2, this has 3. This one doesn't have a side with two tick marks, so I can't say that they're congruent. So these are the only two pairs of triangles that are congruent in this image. All right, let's move on to the next one. For number 2, they gave me a triangle, and then they marked that these two angles are congruent. Well, if these two angles are congruent, then the sides across from those angles are also congruent. So this is an isosceles triangle. You wouldn't want to set the leg length equal to the base. What you want to do is set the two legs equal to each other, because I know the legs of an isosceles triangle are congruent. So we would say 3x minus 5 equals 2x, and then I'd subtract the 3x from both sides. So we would have 2 minus 3 is negative 1x equals, bring down your negative 5, divide by negative 1, or just cancel out your negatives, and I get x equals 5. And then it wanted to know the length of the legs. It did not matter which one of these expressions you plugged x into. I chose 2x because that would be the easiest, and then 2 times 5, so 2x would be 2 times 5, which is 10. And if this leg is 10, guess what? That leg is 10 also, because they are congruent, because it is an isosceles triangle. For number 3, they gave me this angle is 61 degrees, and then they marked these two sides as congruent. Well, if these sides are congruent, then the angles across from them are congruent. It's just the opposite of what we saw for number 2. So I put that this angle is 61 degrees, so the measure of angle A is 61 degrees. We know that all the angles in a triangle add up to 180 degrees. So all we need to do is take 180 and subtract those two 61s. Two 61s is 122. And 180 minus 122 is 58 degrees. And that's it for number 3. All right, for number 4, I just drew this generic triangle. It says we have an isosceles triangle. We have that the base is x. We have that a leg is 2x minus 7. Well, if one leg is 2x minus 7, then the other leg is 2x minus 7. They also tell us that the perimeter is 26. Perimeter is when you add up all the sides of a polygon, right? So I want to add that 2x minus 7 plus 2x minus 7 plus x equals 26, which is the perimeter. You could have wrote a 2 in front of 2x minus 7 to distribute it. The outcome would be the same. 2x and 2x is 4x, negative 7 and negative 7 is negative 14. There's another x here. 4x and x is 5x. To get rid of a negative 14, you would add 14 to both sides. 26 plus 14 is 40. If it's beside, you divide, or to undo multiplication, you divide, and 40 divided by 5 is 8. And that's all they wanted, was for me to find x. So again, it's just remembering that in an isosceles triangle, the two legs are congruent, and that perimeter means you add up all the side lengths. All right, let's look at number 5. From number 5, we had a couple of triangles meshed together. They share this side. They gave me this 66, but that is absolutely it. Now, when you see that these 3 tick marks, that lets me know that all 3 of these segments are congruent. So this would have to be an equilateral triangle. So triangle BCD, this triangle right here, is equilateral. Well, we learned that if it's equilateral, it's also equiangular. So each of these angles has to be the same, and they're all 360. So now I know that this is 60 degrees. And they want me to find the measure of angle ABC. Well, I've marked that in purple. Here's ABC. Well, if I know this little piece is 60, I would just need to find this little piece and add them together. That's the angle addition postulate, right? This little angle plus this little angle make the big angle. So to find this angle, what I did was I seen that these two sides were congruent. Well, if two sides are congruent, it's an isosceles triangle. And I know that the angles across from those sides are also congruent. So if this angle is 66 degrees, then that means this angle is 66 degrees. So just like we done previously, I did 180 minus 2 times 66, and 2 times 66 is 132. 180 minus 132 is 48. So that meant that this angle was 48 degrees. So you would just add these two together, 48 plus 60, and the measure of angle ABC has to be 108 degrees. All right, for number 6. They had this cute little picture of a tent. They told us that this part right here, which was holding the tent up, was 5 feet. I know that that's a perpendicular bisector also. So they want us to find the length of this leg. I just decided to call it X. And this is an equilateral triangle. They also tell us that. So if this is X, this whole bottom is X. So this little section right here, being bisected from the whole thing, would be half of X. So you could write 0.5X, 1/2 X. I just wrote X over 2. And we have a right triangle here. So I'm going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So these are the two legs of my right triangle. So 5 squared plus x over 2 squared equals this side, which is the hypotenuse squared, x squared. I know it's the hypotenuse because it's across from the right angle. All right, 5 squared is 5 times 5, which is 25. X over 2 squared. To square that, I would need to square the numerator and the denominator. So that would be x squared over 2 times 2, which is 4. And then this is x squared. Why I multiplied by 4 was to get rid of that 4 in the denominator. I know you guys do not like fractions. So when I multiply by 4, what that does is 4 times 25 is 100. This 4 up here and this 4 down here will cancel out. And I've just got x squared, which is much friendlier, right? And then 4 times x squared is 4x squared. You want to bring your x squareds to one side, so I subtracted an x squared. 4x squared minus 1x squared is 3x squared. Bring down your 100. Divide by 3. That doesn't go evenly, so I left it a fraction. To get rid of a square, you take the square root. If I do it to one side, I do it to the other. So those will cancel. And I know what the square root of 100 is. This is like the square root of 100 over the square root of 3. The square root of 100 is 10 because 10 times 10 is 100. In the question, they asked me to do a decimal and round to the tenths place. So you just want to put that in your calculator. 10 divided by the square root of 3. And you may be using a calculator on your phone. You get 5.77, and if I round to the tenths place, that will be 5.8. And that's it. That's all they wanted to know was this length. All right, for number 7, we have a couple of triangles, and they want to know if they are congruent. So I have 3 pairs of congruent sides. So that would be side, side, side. Are they congruent? Most definitely. You just need to make sure you've got corresponding parts lined up. So look, if I do NRZ, which is I believe is the way the question was set up. So you see how you go past the side with the 3 marks to the side with the 1 mark. You want to do the same thing over here, the side with the 3 to the side with the 1. So that would be XRW. Okay? All right, for number 8, we have 3 triangles to look at. So just 2 at a time, okay? So when I look at ABC and DEF, I notice we have 1, 2, 3 pairs of congruent sides. So are those triangles congruent? Heck yeah, they're congruent by side, side, side. And now let's look at these 2. Now we don't have 3 pairs of congruent sides, but look, 1 tick mark, 1 arc mark, 2 tick marks. These triangles are congruent. How are they congruent? Side, angle, side. So I can say that triangle DEF is congruent to triangle GJH by side, angle, side. So since triangle, let's just number them here. Since triangle 1 is congruent to triangle 2, and triangle 2 is congruent to triangle 3, guess what? These two bad mamma jammas have to also be congruent. And how do I know that? It's by the transitive property. We used it a bunch when we did proofs before at the beginning of the semester. Usually it was of equality, but since we're talking about congruence, it's the transitive property of congruence. All right, for number 9, they gave us these two triangles. They marked that both of these were D degrees, so I went ahead and drew an arc mark to show that those two angles are congruent. These sides are congruent because they both have 2 tick marks. These sides are congruent because they both have 1 tick mark. So are these triangles congruent? They most certainly are by side, angle, side. So again, side, angle, side. So I could say that triangle DEF is congruent to triangle STU by side, angle, side. They also wanted to know what the measure of angle SUT is. So angle SUT, I marked it right here with green. This angle corresponds over here with angle F. So this would be equal to F degrees. That's all we can say. I don't know what F degrees is. It could be 87. I don't have a clue, but F. That's all we can do. All right, for number 10. They give us these two little measly triangles and they want to know if they're congruent. I have 2 pairs of congruent sides, but that's it. And there's not one on this piece of paper that just says, hey, if 2 sides are congruent, then we're good. So I don't have enough information. I can't say that they're congruent, so there's just not enough info. Not congruent. And then the last one we're going to look at today is number 11. They mark these 2 sides as congruent. They mark these 2 angles as congruent. And then I see that they share PR as a side. So I went ahead and marked that as congruent. So I know that this is congruent to itself. That's the reflexive property, right? And then these 2 sides are congruent. They gave that to me. These 2 angles, QPR and SPR, are congruent. They marked those for me. So yes, they're congruent, and they are congruent by side, angle, side. All right, I will go over the second half tomorrow. I hope you have a wonderful rest of the day.